Let's look at type 2 binary compounds and how to name the compounds and then how to determine the formula from the compound's name. And in type 2 binary compounds, we're looking again at metals bonding with nonmetals. Metals like to become cations when they bond. They lose their valence electrons and take on a positive charge. Nonmetals are anions. They gain electrons in their valence shell and obtain a negative charge. Type 2 binary compounds are where we are using metals that are transitional metals. Those metals that have more than one common charge on their ions. Whereas type 1 binary compounds are where the metal has only one particular charge on its ion. Okay? So let's have an example here. Here's an example. We have FeO, and then let's also have second one, Fe2O3. Here are two compounds. Okay? Both contain iron and both contain oxygen. Okay? But iron is a transitional metal. So it forms cations, positively charged ions, but its charge will vary from compound to compound. And so we have to recognize that. So when we use transitional metals, we name them similarly as type 1 compounds. We still identify the two elements involved, iron and the oxygen, on both of these. Similarly, as type 1 compounds do, we take the anion that is involved here, which would be oxide. We change that ending on both so that we have an oxide, okay, to represent that anion. But both of these compounds cannot be called iron oxide, because if they are, how do we know which iron oxide? So we have to add an additional detail when naming type 2 binary compounds. That detail is the charge on the irons, on the cation. We have to label that in the name. So we can differentiate between FeO and Fe2O3. So what is the charge of that iron? Let's use our ions table. We know that all compounds are charge neutral. Oxide is commonly a -2 charge. We know that compounds have a neutral charge, a 0 charge. So this single iron cation must be a +2 charge to go with that -2 to equal 0. On this compound, we have 2 of the Fe's, 3 of the oxides. Again, compounds are charge neutral. Each one of these oxides are carrying a -2 charge. So that's giving us a total of -6. Each one of these iron must be carrying a +3 charge. +3 and +3 is a total of +6. 6 minus 6 is equal to 0. So how we differentiate the names of these two compounds, we use their charge so that we can recognize which iron is present in either compound. So this would be iron. Use Roman numerals to represent the charge in the name. 2, Roman numeral 2, to represent that plus 2 charge. And here we would have iron oxide, but we would need to represent it with the Roman numeral 3. So we would have iron Roman numeral 3 to represent the charge of the individual iron cations here. Iron 3 oxide. Okay. Let's try another one. Here's a formula. CuBr. Okay. We first recognize that copper is a transitional metal. We label our elements involved, copper and bromine. We know that on these binary compounds, we need to change the bromine to bromide. The anion gets changed. So let's go ahead and do that. So we have bromide. But we're missing one detail, and that is the label of this copper. So we need to determine its charge. Bromine, when it becomes the anion bromide, it carries a -1 charge. Copper is a transition metal, so it may be varying charges. But we know that together, our cations and our anions add together with a 0 net charge on our compound. So this individual copper must be a +1, because 1 minus 1 equals 0, and compounds are charge neutral. So the proper name for this compound is copper 1. Use the Roman numeral to represent the charge of the individual copper. Copper 1 bromide. Copper 1 bromide. Now, let's reverse this. Let's start with the name and then generate a formula. Okay. Let's try cobalt 2 chloride, and let's try nickel 2 oxide. Okay, first thing, we recognize we have cobalt, CO. We have chloride coming from chlorine, so we have our two element symbols involved. Cobalt and chlorine are the two elements here. So that's our two ions, this chloride ion and this cobalt ion. But we need to represent their charges so that we can determine that proper ratio. Chloride carries a -1 ion charge. Cobalt is a transitional metal. The Roman numeral tells us it's carrying a +2 charge. Those are our two ions, the cobalt +2 and the chlorine with the -1 to be the chloride ion. To get the proper ratio so that charge neutral occurs with the compound, we again do the crossing over. Cobalt, chloride, and 2 right here. Okay. To check ourselves, to make sure it's charge neutral, our cobalt is carrying a +2 charge. We have two chloride ions, each one with a -1 charge. 2 minus 1 equals 0. That's charge neutral. So cobalt 2 chloride is CoCl2. Now, let's try it here with the nickel 2 oxide. Nickel is Ni. The Roman numeral is telling us that the nickel is carrying a +2 charge. Oxide ion is coming from oxygen, and oxide carries a -2 charge. So here are our two ions involved. We again do the crossing over to get Ni2O2. But now these ions, we should show them in their simplest whole number ratio. So 2 and 2 is really a 1-to-1 ratio. So it would be listed as NiO, nickel to oxide, with the 2 being representative of the charge on the nickel. Okay? Hopefully this will help with naming type 2 binary compounds where the metal cation is coming from a transitional metal that has varying charges.